Good afternoon, students. Okay, this is the in 6th semester elective paper is a sixth semester elective B paper. It is a vector calculus we have. So vectors, you have the concept about the vectors and scalars. So if you have studied the intermediate, you will have already knowledge about this one. Okay, vector calculus. So you can see the definition of this one, or else how it is defined as a vector calculus is. Vector calculus, also known as, we call it even it as a vector analysis. So this vector analysis deals with the differentiation. So you know in the first semester you have the concept of differentiation and also integration. So vector analysis or vector calculus, it deals with differentiation and integration of vector fields. Okay, so of the vector fields, on that we'll study about the differentiation and integration, especially in the three-dimensional Euclidean space. So already in 3D, in 5th semester, you have seen that 3D is the three-dimensional geometry. So in that you have the concept of the three dimensions, that is X, Y, Z. Three axes will be there. So 2D means only two axes, X and Y axis. So this differentiation and integration of the vector fields, especially we deal in the three-dimensional Euclidean space, that is we call it as R3. Okay. So here, first one is we have the concept of what are the vectors. So if you see in your textbook, in unit 1, block 1, you have the all the concept about the that is the introduction of what are the vectors, what are the examples of the vectors, and what are the scalars and examples of the scalars. And regarding of that one, many concepts are there, and example problems are there, and also worked out exercises are there. So many problems are there in block 1. That is whole, that is a standard, means basic concepts of vectors and also scalars. So you know already the pattern of the book, that is how the syllabus is divided. So it is divided into 4 blocks. So first block is about vector differential calculus. Block 1 it is. Block 1 is about okay. So block 1 is vector differential calculus. So this is a block 1. So in that unit 1 is basic vector algebra. That is a basic concept of the vector. In that vector algebra means it is the addition of the vectors or subtraction of the vectors or multiplication of the vectors. Okay. So that is about the basic vector algebra. So basic vector algebra, in this you have the concept of what is a vectors. So you know that vector means it is a physical quantity having both direction and also magnitude. Okay, the quantity which have magnitude in the sense some length or value. Okay, So if any quantity, either it has a magnitude and also that means it has some value, and also direction means in which direction it is moving, either east or west or north or south. So, but it should have some direction, okay? Such type of quantities are called as the vectors. So if you see, vectors means they have a physical quantity having both magnitude and direction. Okay, it is called, those are called as the vectors. We can take the example as displacement, force, okay, velocity, and also acceleration. Okay, these are the examples of the physical quantities which have both magnitude and direction. Okay, force means we'll write some, it has a joules, no? So we'll represent the force. We are doing the force in which direction? Some direction you will do, no? Displacement also traveling. So in one direction we'll travel. So that's why some length will travel, and also it has some value also. And the direction also it has. So these are the examples of this one. So that is work or distance or anything. Force means will represent as it as some quantity will represent, that is 5 newtons. So anything if we represent like this, force is equals to 5 newton in any direction if it is represented east. The force you are giving it in the east direction, and the force of that one is, this is magnitude and this is direction. This is magnitude and this is direction. Okay. So such type of quantities are called as a vectors, and usually we represent the vectors with a small letter, that is a small a or capital A, any alphabets. So vectors are denoted by like this A. On that you put the arrow mark. That means it is having the direction. Okay. Or in some textbooks you will have dark A, that is. Okay. Or it is a dark A. Or on the A, it is represented as an arrow mark, and this whatever the arrow mark is there, this is called as a tail, and this is called as head. Okay, so we put the arrow mark on that, means it represents it as a vector. Okay, and the magnitude of this whatever vector is there, magnitude of A is will represent it as modulus of A. Okay, that is we'll put the 2 lines. Even we call it as a modulus or length or else determinant. So 2 lines will be there, and in that will represent the vector. Okay, or length, or it is called as a magnitude or length or modulus. So you can call it in any 3 ways. So magnitude of A is, that is modulus of A or length of A. And if any vector is there, if is asking to find the magnitude of that one, means we'll find the modulus of that one. Modulus of that one is, if you think any vector A is there, so 2i plus 3j plus 4k is there. Okay, Then magnitude of A is, that is A modulus is equals to root of 2 square plus 3 square plus 4 square. Okay, 2 square is 4, 4 plus 9 plus 16. 4 square is 16, 3 square is 9, 2 square is 4, 6, 4, 20, so 29. It is root 29. Like this, we'll find the magnitude of any given vector. Okay, this concept is useful for solving the problems. And next, this is about the vectors. And if you go to about the scalars, means scalars will have only the magnitude will be there. It will not have the direction. So scalars means usually these, whatever the real numbers are there, the numbers which have only the value, such type of are called as a scalars. Okay, we can take the best example. If all the real numbers, we can take them as the scalars. They have only magnitude, means they have some value, or the quantities which have only some length or the value, that such quantities are called as scalars. So scalars means only magnitude will be there. Okay, no direction, only magnitude. And example you can take. So you can write the definition as a physical quantity which have only magnitude is called as a vectors. Okay. For example, mass, temperature, and pressure. Okay, temperature means we'll write it as 30 degrees Celsius or something, but we'll not mention it any direction, east or west or anything. Our mass also means we'll that is kgs. Pressure means we put the pressure on anything, but it will not have the direction. So these three are the quantities which are only magnitude but no direction. Okay. So in objective type of question, they will ask what are the examples of the vectors and also scalars. Okay. So next concept in the block 1 in the unit 1 is about the types of vectors is there. So different types of vectors will be there. In that, first one is the equal vectors. Okay. So equal vectors means they should have compulsory in the same direction. If the two vectors, if they go in the same direction, then only. And also magnitude, if they have the same length and also same direction, then such type of vectors are called as the equal vectors. So in types of vectors, first one is equal vectors. So equal vectors means same direction and magnitude. Okay, like this you can make. So same direction and also they have equal magnitude. Okay, next one is a zero vector. This is the important one. Zero vector means which have zero magnitude. So the length of that vector is 0 and it may go in any direction. Okay, particular say only in one direction we can't say. The direction is in any direction, but the magnitude of that one is, you can take the magnitude means the magnitude, if it is 0, then we call it as a zero vector. It has 0 magnitude. So it is in any direction. So specific direction is not mentioned here. 0 magnitude and denoted by, so in problem somewhere you will see this one, denoted by 0 vector or some like it is stressed. That one it is mentioned as a O with the dark shade. Okay. So even zero vector, it is also called as null vector. So remember this, and representation of zero vector, how it is represented, it is important. And what is the magnitude of zero vector means it is 0. Okay. Next, third one is a unit vector. So in the name itself, it is there. Unit means 1. So which has a magnitude 1, it is called as a unit vector. So third one is unit vector. Magnitude as 1 unit is called as a unit vector if. And for this one, unit vector, in solving the problems, we'll use the representation of what is the unit vector, how it is defined also. It's important. So wherever we'll find the unit vector, we'll apply one formula to find the problems. Okay. Unit vector means magnitude has 1 unit. One unit is called a unit vector. So all these definitions are there in your textbook. So you can see from the textbook. Unit vector, if any A bar, that is vector A is there, is a vector then this is the important one. Unit vector means it is represented like this. So vector A by modulus of A, that means it has a direction and also it has the magnitude as 1. Okay. So magnitude as 1 and the direction, it goes in the direction of the 1 unit. So then vector A divided by modulus of A is vector with unit magnitude. Is vector with unit magnitude. And the representation is also there. And it goes in the direction of A, that is a vector A. And it is denoted by A cap. Instead of this arrow, we'll write it as denoted by A, like this cap will be there. So if for any value it is there on the above, if you have arrow mark means it is a vector, and if like this cap is there means it represents that it is a unit vector. Okay, it is called as A cap. Okay, for solving the problems, if anywhere unit vector is there means you have to find the unit vector value by, that means vector divided by modulus of that given vector, then you will get the value of the unit vector. Okay, so in solving many problems, we use this concept. So this is the important one, and unit vector. Next, we have that there is a negative of a vector means same magnitude but having its direction opposite to that of A is called as a negative of A. So normally, just I am giving the here just as an example I am telling. So no need of writing the definition, whole definition. If you want, you can see from the textbook it is negative of a vector. So negative of a vector means will normally any vector means will represent of like this. So negative of vector means minus A. So instead of plus, you will have the minus, and vector A will be like this direction. If A to B, this is the vector A. Okay. Negative of vector A means from B to A. Like this representation, okay? So negative in the sense, instead of positive, you will have the negative value. So this is about negative of a vector. Next, we have the co-initial vector. Co-initial vector means vectors having same initial point are called as a co-initial vector. Co-initial vector means, diagram you can represent like this. This is from O, point O. They have the initial point here. Two vectors, if they have the same initial point, then we call it as a co-initial vectors, okay? This is B and this is A. This is vector A and this is vector B. So vector A and vector B have the same point as the initial point, okay? Vectors having same initial point are called co-initial points. So this is the initial point of vector B and also this is the initial point of vector A. If they combined at one point O, then such vectors are called as co-initial vectors. Vectors having same initial point are called as co-initial vectors. Okay, next we have non-zero vector means whose magnitude is not zero. In the name itself, it is there non-zero vector means which has some value. Instead of zero, it has some magnitude. Okay, so it is called as non-zero vector. Next we have rectangular unit vectors. So this is the important one. So we for the rectangular unit vectors, we represent the rectangular Cartesian coordinate system. That is X and Y and Z axis. They will have the directions. You know that along with the positive directions of X, Y, Z axis are called rectangular unit vectors I, J, K. So these three will be mutually perpendicular to the x-axis, y-axis, and z-axis. So such three vectors are called as rectangular unit vectors. These are mutually perpendicular to x, y, z axis. So definition is there. So that's why for any representation of the vector, we represent with the I, J, and K. So it shows that I is in the direction of the x-axis, J is in the direction of the y-axis, and K it is in the direction of z-axis. Okay, it is about the rectangular unit vectors. So rectangular unit vectors means in rectangular Cartesian coordinate system, the unit vectors along the positive directions. You know that they will have negative direction and also positive direction. So if they are in the positive direction of x, y, z axis, then they are called as rectangular unit vectors and they are denoted by I, J, K. Okay, like this if you see the diagram. Is x or so this is x, y. Okay, so here unit vector along the x-axis is I and the unit vector along the y-axis is J and here it is K and they are mutually perpendicular to this one. So the I, J, K are called as a rectangular unit vectors. Next one is the important one, that is the algebra of vectors. So properties will be there here. So what the vectors are satisfying the properties. So with the help of that, we can solve some problems. So algebra of vectors. First unit itself, it is the basic algebra is there, vectors. So in that, what is the addition of the vectors? Algebra of vectors. In the first one is addition of vectors. So if any vector or two vectors are there, A is one vector and B is another vector. So what is the addition of those two vectors? How we'll solve that one is, so sum of vector A and vector B can be found by two laws are there. With the help of those two laws, we can find the sum of the two vectors. So first law is triangle law of addition and second law is parallelogram law of addition. Okay. With the help of these two laws, we will find the addition of the vectors. So sum of vector A and vector B so can be found by triangle law of or parallelogram law. So with the help of these two laws, we'll find the addition of the vectors. If we take the first one, that is the triangle law of addition. So in this, if you take here any vector with the AB. So if you take this as vector A and from B to C, this is the direction of this one and this is the vector B. So here we represent it as C. Okay. So we know this is the tail and here you will have the head and again we'll join it with the tail of another vector to the head of that one. Okay. So triangle means here whatever the initial point of this vector is there, this you will join it with the end point here, end point of the vector C. So here from the initial point of this line to here C, whatever will join this one, it is vector C and this is vector B. Okay. So here whatever it is there, A to B, it is the vector A and B to C, it is the vector B. So whatever it C represents, it is, we can write C which is equals to A vector plus B vector. Okay. So this is the triangle law of addition. That means vector A plus vector B. What is vector A to B plus vector B is B to C. It is equals to, what is this? If you combine these two, you will get this distance only. So that is equals to AC. Okay, like this, if we find it is with the help of triangle law of addition, we can find the sum of two vectors. And if we go to the parallelogram law means, next parallelogram law of addition. So in this, you have to draw the diagram of parallelogram. So this is the parallelogram A, B, C here and D. So this is vector A and this is vector B here. So whatever the diagonal we have, two diagonals we will have. So this AC is one of the diagonal and BD is the another diagonal. So how we have got here, that is from here initial point to the end point of this vector, whatever the distance is there, That is the sum of the two vectors. Here also, if AD is the vector B and AB is the vector B, AB, whatever distance is there, it is of the vector A, and AD is the distance of the vector B. Okay. So if you add these two vectors, you will get whatever the diagonal is there, AC. So you will get it as a sum of the two vectors. So you can write here it as vector A plus vector B is equals, what is vector A? AB plus AD. This AB and AD. So it is equals to AB plus, instead of AD, we can write BC also. No? So BC. So AB and BC means it is equals to AC. So which is equals to the sum of two vectors. Okay. So this is about the parallelogram law of addition. So these two, whatever the distance is there, it is equal to the diagonal distance. So sum of two vectors is equals to AC. So in this also and in this also, with the help of this, we can find the addition of two vectors, and also it is represented as vector A plus vector B. Next we have the subtraction of vectors is there. Okay, subtraction of the vector means vector A minus vector B. So subtraction of the vectors will be not there. Just we'll write the subtraction in the form of addition only. How means just in place of B, you write it as minus B. So subtraction of vector means that is A minus B. We'll write it as vector A plus minus vector B. Okay. And next we have the properties of addition are there. In the addition, some properties are there. That means it satisfies the commutative law. So commutative law is A plus B equals to B plus A. And also it satisfies the associative law. In vector addition, associative and commutative properties both will be satisfied by the vectors. Properties of vector addition are first one is commutative property, or we can call it as commutative law or commutative axiom, anything. So vector A plus vector B is equals to vector B plus vector A. So it satisfies this property, and also second one is associative law. So associative law means A vector plus B vector plus C vector is equals to A vector plus B vector plus C vector. So it satisfies these two laws by the vector addition. Okay. Next, collinear and coplanar vectors are there. So these two topics are important. Collinear vectors and also coplanar vectors means, collinear means if the lines of support are either same or parallel. Or else if you see in the normal definition means if they lie in the same line. So if two vectors, if they lie in the same line, then we call it as a collinear vectors. The vectors which lie in the same line, or the, if you'll see in the another definition, that is a collinear points will be there. That means the points, if they lie on the same line, then we call it as a collinear points. Here we are talking about the vectors. So if two vectors, they lie on the same line, then we call it as a collinear vectors. So for that also properties are there. That is, if A is one vector and B is another vector, so these two are called as a collinear. So the conditions are that first one is their directions are same. So the directions may be in the same or in the opposite direction. Okay. These two cases arise. One is in the same direction, another one is opposite direction. So their magnitude may differ. So they may have same magnitude or different magnitude. So they may or may not be co-initial vectors. That means the end point of these two may join together or they may not join. Okay, that is they may not have the co-initial vectors. So collinear vectors means one vector, it is equals to the sum of the scalar quantity will be there of the another vector. So collinear means almost will represent this one, that is A, vector A equals to K into vector B. So they lie on the same line. And also usually we represent it as like this. A vector is equals to K into K is here scalar. Means some value it will have. So like this, if you represent the collinear vectors, and if we see the coplanar vectors means, so any two vectors are always coplanar. That means they lie in certain plane, in any plane. So these two vectors lie in that plane. So such vectors are called as coplanar vectors. So if they lie on the same line, so somewhere here vector A and vector B like this, it has some direction like this. So if they lie on the same line, then we call it as a collinear vectors. If any plane is there, you think this is any plane. So here vector A is there. Here you will have vector B. Here you will have vector C. So if they lie in the certain plane, then we call it as a coplanar vectors. Okay. So two vectors lie in the same in the given plane, but three vectors, they may or may not be coplanar. Means they may or may not lie in that plane. So it may be outside the plane. So then three vectors, sometimes they may not be coplanar. Two vectors will be coplanar. Okay. So this is the definition of the collinear vectors and also coplanar vectors. So on these problems will be there. They will ask for 5 marks questions. So in the textbook, you have the definition of coplanar vectors, a set of vectors which lie on the same plane or whose lines of support are parallel to the same plane. That is vector A, vector B, vector C are coplanar if there exist scalars m, n such that coplanar means. So this is the representation of the collinear, no? So coplanar will be so it is represented as like this. C vector is equals to MA plus NB. M and M comma N are here scalars. M comma N are scalars. Okay. So you'll get the problems like this. That is if A vector A comma vector B comma vector C are non-coplanar vectors, then show that the points, 3 points are given. You have to show that they are collinear. So we'll see one example on collinear vectors and also coplanar vectors. Non-coplanar vectors. Okay, then show that the points. Then show that the points. First one is minus 2A. Comma A plus 2B plus 3C, and third point is 7A minus C are collinear. We have to show that these points are collinear. The given points are here, these three. So you can take that is represent those 3 points as point A, point B, and point C. Let us denote the points as given points as A, comma, B, comma, C. Okay. So the position vectors means if you take from origin to point anyway, O to A. If you have B here, means we'll take it as O to A and O to B. No, so these are called as the position vectors of the given vectors. Vector A means the position vector is OA. Position vector of B is OB. If we have C means OC. Okay. So like that, if we take 3 points, means it has the position vectors are the position vectors of given points are OA, means OA is equals to, this is minus 2A plus 3B plus 5C, and OB is equals to A bar, that is vector A plus 2 plus 3C, and OC is equals to CA minus C. Okay. The position vectors of the given points is this one. So now we need to find that they are collinear, no? So we need to find the distance between AB and AC. So what is the representation of collinear vectors means vector A should be equal to some scalar into the vector B. So now AB is equals to, what is AB? AB is OB minus OA. So what is OB? OB is minus OA. Minus of minus is plus 2A minus 3B minus 5C. This is 3A. 2B minus 3B means minus B. 3C minus 5C means minus 2C. Okay, this is AB. And if we see the AC, or we can take BC, anything. Okay, so 3 points are there on the line A, B, and C. Okay, so here if so they are collinear means they lie on the same line. If we are finding AB or BC or AC. Okay, anything we can find. AC is equals to OC minus OA. So OC is what? 7A minus OA is minus of minus is plus 2A minus 1 minus 3B minus 5C. So 7A plus 2A means 9A. B is not there, so minus 3B like that only, right? Minus CA minus 5A means minus 6C. So you can take here 3 common, no? So if you take out 3 common, three threes are 9, so 3 vector A minus vector B minus 2. What is this? 3A minus B minus 2C. 3A minus B minus 2C. it is equals to AB. That is, it is equals to 3 into AB. Okay. You can write here from 1. So from 1, that AB is equals to 7. Therefore, AC is equals to 3 into. So it is in the form of collinear, whatever representation is there. So therefore, here AB and AC are collinear. Hence, the points A comma B comma C are collinear. Hence, the points A comma B comma C are collinear. Okay, like this you have to solve the problem when the 3 points are given. If we want to show them as a collinear means one, whatever the combination of vectors, it should be equal to sum of some scalar you have to get and into the another vector. Okay, if you'll get in that way, then that means the 3 points lie in the same plane, and we call that the vectors are coplanar vectors. Next, another one is about coplanar. Coplanar means one is whatever the form just representation I have given, no, that vector C is equals to M into vector A plus N into vector B. With the help of that we can do, or else with the help of the determinant also. If the determinant value is equals to 0, then we call it as a coplanar vectors. Okay. And if the determinant value is not equals to 0, means the given vectors are non-coplanar, means they do not lie in the any plane. So example is determine whether the vectors are 2i minus j minus k, comma ti minus 4j plus 5k, and 2i 4j minus 6k are coplanar. Now solution is directly we can write it as, so coplanar of vectors means that is determinant we can take, and if you find the determinant of that one, so we can take the points as, that is vector A equals to given point and vector B equals to second point and vector C is equals to third point. So shortcut method we are doing this one. So we can represent them as A, B, C vectors. We can take here, let A is equals to 2i minus j minus k. B is equals to 3i minus 4j plus 5k. And C is equals to 2i plus 4j minus 6k. Okay. Vector A, comma B, comma C are coplanar if vector A, comma B, comma C are coplanar, then is equals to 0. Okay. If they are coplanar means the triad of A, B, C, if it is equals to 0, then we call that the vectors are coplanar. Okay. So for that we'll find here determinant of the coefficients of ijk. That is 2, -1, -1. Okay. 2, -1, -1. 3, -4, 5, 2, 4, -6. Okay, this is the determinant of the ABC vectors. So I hope so you know how to find the determinant, that is 2 into, if you eliminate that row and this column, whatever the minor is there, that minor is minus of minus is plus 24, minus 5 fours are 20, minus of minus is plus 1 into, if you eliminate this column and this row, 6 threes are minus 18, here minus 5 twos are 10, minus 1 into this row, this column and this row means 3 fours are 12, plus 4 twos are 8. So it is 2 into 24 minus 20 means 4, minus 18 minus 10 means it is minus 28. 12 plus 8 means 20. That is minus 20. So minus 20 and here 8 you will get. This is minus 48. It is equals to minus 40, which is not equals to 0. So we didn't got the value as 0. Therefore, it is non-coplanar. The given vectors are non-coplanar. Therefore, the given vectors are non-coplanar. Okay. If we'll get as it is equals to 0, then the 3 vectors are coplanar vectors. So this is the concept of collinear vectors and also coplanar vectors. And one more is that is the orthogonal of the vectors will be there. So if show that the 2 vectors are orthogonal vectors means you have the concept of the that is orthogonal means they are mutually perpendicular to each other. They are mutually perpendicular to each other means A dot B equals to 0. So this is about the collinear and coplanar of the vectors. Next, we have the concept of the dot product or scalar product of vectors. This is the important one. There is a dot product or scalar product. Or scalar product of vectors. Okay, dot product of scalar product of vectors means 2 vectors. If A is one vector and B is another vector, this is called as dot product. If dot is there in between of them, then how we'll find the dot product of 2 vectors. Vector A dot vector B is equals to, that is magnitude of A, magnitude of B vector into cos theta. Okay, and theta lies in between 0 and 5. Okay, theta is the smallest non-negative angle between. Theta is smallest non-negative angle between A and B. Okay, so this is the dot product or scalar product of two vectors. And in this, one note is that dot product of two vectors is a scalar. So when you do the dot product of two vectors, whatever the resultant answer is there, that will get as a scalar one. That means you'll get some value. Okay. And the dot product satisfies even the commutative property also. Dot product of two vectors is a scalar. And the dot product satisfies of two vectors is commutative. That is A dot B is equals to B dot A. So it satisfies the commutative property also. And one for the dot product, you will have the condition for orthogonality, or we call it as a condition for perpendicularity. Okay, condition for orthogonality or perpendicularity. So the condition is that A dot B is equals to A dot B is equals to 0. Okay, this is the important one. Just now we have seen the problem. No, that is the condition for orthogonality, or if two vectors are mutually perpendicular means what is the condition means? The condition is A dot B is equals to 0. So whatever the answer, if you get it as 0, then the two vectors are mutually perpendicular to each other, or they are orthogonal to each other. And in this, and you remember these conditions also, if it is a dot product means I dot I is equals to 1, J dot J is equals to 1, K dot K is equals to 1. Okay, dot product of two same vectors will be, that is I dot I or J dot J, K dot K is equals to 1. So if I dot vector J we have means we get it as 0, or J dot K means we get it as 0, or K dot I means we get it as 0. So remember this one while solving the problems. You will find this one. That is I dot I is equals to 1 and J dot J equals to 1, K dot K is equals to 1. Okay. And this is the condition for perpendicularity. No, if two vectors are parallel vectors, then we'll have if two vectors, if A are parallel vectors, then vector A dot vector B is equals to modulus of vector A modulus of vector B cos 0 degrees. Means two parallel means the here theta will be 0 degrees. Cos 0 degrees, it is equals to mod A and mod. Okay. Here the condition is if A and vector B have same direction. If they have opposite direction, If they have the opposite direction, means A dot B is equals to here the angle will be cos pi. So we will get it as minus mod A mod. Okay. So this is about the concepts of the vectors and scalars. So tomorrow we'll see some more concepts about the vectors and scalars, and also even the cross product